Let us suppose we have a function y is equal to f of x, and our goal is to approximate this function using a neural network. What you see here is the simplest possible setup. You see one input, one output, and one neuron. Neuron and input is connected using a weight w1, and it is connected with the output using a weight v1. This neuron is really the core building block of neural network, and it does just two things. First one is the linear combination, and the second one is the activation function. So how to do the linear combination? It's really simple. Simply multiply the input with the weight. So this is the first step or first operation of the neuron. In the second step, we do the activation. So this value of z is actually passed through a nonlinear function, let's say sigma, which introduces nonlinearity. So how to do that? Let's call it h sigma z. So this z value is actually passed through a nonlinear function sigma. There are many types of activation functions, but one of the most popular activation functions is sigmoid function. So if we use that, it will be written like this. Okay, so this was the second step. Finally, this output is scaled by another weight v1, because neuron is connected with the output using this weight v1, and we will produce the final estimated output. So we will get our estimated function v1 h. So this is the final form of the estimation, or we can also write it like this: v1 sigma of z. So even with just one neuron, we have already developed a neural network which shows us a nonlinear mapping from input to output. And that's the basic idea behind neural networks.